Welcome back to Cisco Networking World. In this video, we will continue the concepts of Cisco Networking Phase 2. You may be thinking that we are still in the concepts of networking. What's going on in this video series? Of course, we are still in the concepts of networking because I believe that for building a strong career in networking or any technology, the basic concepts of the technology are the key elements to become the superhero of the technology. And also in real world networking, soon you will realize that the concepts of Cisco networking technology are the building blocks for networking. So the concepts are most important. This is the reason this video is a lengthy video, since we are going in details of every concepts of networking. So guys, join with me to become the superhero of Cisco networking technology. So if you are ready, let's begin right where we left in our previous episode. We successfully joined these employees to our international networking company network. We also connected these resources, printer and database server, to our INC company network. Now these end users can share files and folders. Technically, they can communicate with each other and they can utilize these resources. This type of network, we call it as LAN network, local area network. What is a local area network? A local area network is a group of computers, printers, servers that share a common communication link within a small geographical area, such as an office building or campus. The great news about our international networking company is that its business is growing day by day, and INC company branches and its employees are also growing simultaneously. By the way, I have an advice for you guys. Once you complete this full CCNA series, apply for the job as network engineer in INC company to maintain this beautiful network. but on a serious note, watch all the videos in order and each video from beginning to end to acquire full knowledge in all aspects of Cisco networking. And do remember to subscribe our channel for future upcoming videos. Our INC company is growing. They started a branch in another city. Okay, you can see on the screen. Now we have two LAN networks, a LAN network in Hyderabad head office and another LAN network in Bangalore city. But you can see on your screen that there is no connection or link between these two offices. So without a connection or link, these two networks cannot communicate with each other, neither they can utilize resources available in any branch. So we have to build a connection between these two branches or these two networks. So now let's talk about the options or solutions are available to connect these two INC company networks. We have two options to connect these branch offices, option A and option B. Let's talk about option A. We can connect an Ethernet cable between these two branches, that is a connection from head office switch to the branch office switch. As we plug an Ethernet cable between these two branches, between these two switches, then it will be considered as a local area network, a LAN network. Once we connect these two switches, now this whole we call it as local area network. But is a big factor here, because running an Ethernet cable all the way from Hyderabad to Bangalore is just not possible, because approximate distance between these cities is more than 500 kilometers. And the other reason could be that the government agencies will not allow companies to run their own Ethernet cables all around the country, because there may be hundreds or thousands of companies. If government allow these companies to run their own Ethernet cable, the whole country will become a mesh of cables. By the way, not every country has these similar regulations. Maybe some countries allow companies to run their own Ethernet cable through branch offices with the permission from the government. It depends in which part of the world you are. Even though the government allow companies to run their own cables whatsoever, the companies will not spend hundreds or thousands of dollars to run an Ethernet cable between two branches. One more reason I think is that company will not run their own Ethernet cable between branches because most of the time the branch offices will be in rental buildings. As the rental contract ends, maybe company has to move or shift their branch office to some other location. Now their Ethernet connection to that office is of no use. It's just waste of huge money. So companies, organizations, business sectors rarely uses option A. As a matter of fact, option A is a bad option in most of the countries. So guys, now let's talk about option B. This is the actual option all companies, organizations, business sectors, even government agencies are using this type of connections to connect their branch offices. This is the legitimate type of connection the companies or organizations are using to connect their branch offices within cities, states, or even nations. So what is option B? ISP, Internet Service Providers. ISPs serve large number of companies providing a direct connection from the company network to their branch office networks. However, company has to pay a monthly fee, monthly charges to ISP for this type of connections depending on type of connection. However, we are not going in details about the connection types. I will discuss in details about WAN connection and its type in upcoming video in this series. ISPs also provide internet connection to the companies so that their employees can utilize internet access. So ISP provides links between branches and also ISP provide connections to internet. Just refresh your mind guys. Do you remember what is a switch? Switches are used to connect computers, printers and servers etc. within a building or campus. Here we are using this switch to connect these computers, printers and server in same building office. But our requirement is to connect these two branches or these two different networks. To connect different networks, we require another networking device. So let me take this opportunity to introduce you another networking device, that is this Cisco router. This is the box that rocks. So what is a router? A router is a device that forwards data packets along networks. What are data packets? We already discussed in our first video. Check out my video on that. A router is connected at least two networks. So in our example also we are connecting two different networks. A router is connected at least two networks, commonly two LANs or WANs or a LAN and its ISP network. Routers are located at gateway, the place where two or more networks connect. We are not discussing full function of gateway right now. We will discuss about gateways in upcoming video in this series. Routers are also used to connect company network to the internet through an ISP. In our scenario, we are connecting these two branches, so we required two ISP connections. I emphasize two ISP connections. I am not saying two ISPs. I am saying two ISP connections. One ISP connection at Hyderabad head office and another ISP connection are also required at our Bangalore branch office. By the way, ISPs has connection around the globe. That is the reason we have internet connection throughout the world. Once this connection setup is completed through ISP, okay, then these two branches can communicate through these ISP WAN links. The employees of these branches can share files and folders and also utilize resources available in any branch, either in head office or branch office. This type of network connection through ISP is known as WAN network, wide area network. Now let's talk about types of networks. There are few types of networks, but most commonly we will talk about LAN and WAN networks. Local area network. A local area network or LAN consists of a computer network at a single site, typically home or an individual office building or campus. A LAN is very useful for sharing resources such as data storage and printer. LAN can be built with a network device such as switch, which we already discussed, network adapter and Ethernet cables. So network adapters and Ethernet cable we will discuss in network structure topic in upcoming slides in this video. WAN, wide area network. A wide area network or WAN occupies a very large area such as cities, states or even entire nations. A WAN can contain multiple small networks such as multiple LANs. The Internet is the best known example of a public WAN. WANs can be built with a network device such as routers. Understanding the actual definition of LAN and WAN networks in real world networking is absolutely essential. So guys, now we will walk through a real world scenario example to understand the actual definition of LAN and WAN in real world networking. We will try to understand how these terms LAN and WAN are used in real world. In this topic, we will go a bit beyond the CCNA exam scope, but most essential in real world networking. This knowledge will definitely assist you when you join as network engineer in an organization. So let's begin. This is our International Networking Company campus. INC company whole campus area is approximately 11 kilometers between head office to branch 1 and branch 2. This whole area is INC campus and under INC company authority. So as a network engineer, our task is to build a network connection between head office to branch office 1 and from branch office 1 to branch office 2. In our INC head office, there are 35 employees and we already fixed 2 Cisco switches each of 24 ports and connected all users and resources through UTP Cat6 Ethernet cable to the switches, and all the employees can communicate with each other. Now at our head office, we have fully functional local area network. However, this is not shown on this slide, but let's assume that we have built LAN network. Likewise, we have already built a local area network in branch office 1 and at our branch office 2. The local area networks we have already completed. Finally, our task as a network engineer is to connect all these switches through Ethernet cable from head office to branch office 1 and from head office to branch office 2, and also a connection from branch 1 to branch 2 as an redundant or backup link. If this primary link or main link goes down or fails between head office to branch office 2, still the employees or staff members in branch office 2 can reach head office through this backup link. However, the connection design methods, redundant link, primary and backup links, this stuff we will talk in upcoming future videos in this series. However, this complete is INC campus area, so there are no any restrictions or issues to run Ethernet cable from head office to branch office 1 or from head office to branch office 2 or a backup link from branch 1 to branch 2. Once we complete the Ethernet cable connection, this whole network will consider as local area network, a LAN network of our INC company. Guys, you may be thinking to ask a question to me. Tazeen, there is also INC sales branch which you have not included in your previous discussion. Moreover, you have not joined this sales branch to INC local area network. You are right, my friends. I appreciate your observation. As a matter of fact, this INC sales branch is not physically located in INC campus area. This sales branch is beside the road. By the way, this is the road between head office and INC sales branch. This is the reason I have not included this INC sales branch to INC local area network. Whatsoever, we have to join this sales branch to our INC company network. The distance between these two switches is of just 700 meters. To join this sales branch to INC network, we can just run an Ethernet cable from this head office switch to INC sales branch switch. As I plug this cable between these two switches, this whole INC network will be considered as LAN network or local area network. But let's suppose that due to government restrictions or country policy regulation, INC company is not authorized to run an Ethernet cable between head office to this sales branch through this road. So guys, what is the second option available for INC company to connect these two networks or these two branches? You guys are wonderful. Yes, the option is ISP, Internet Service Provider. Guys, you can see on your screens that these two networks are perfectly connected through ISP network. By the way, ISP has their connections all around the cities, states and entire world because ISPs are legal authorities to build their network connection throughout the world. This type of connection through ISP is known as WAN network, wide area network. Guys, I can read your minds through YouTube channel network that you may be thinking that few slides back Tazeen explained the definition of WAN. A wide area network or WAN occupies a very large area such as cities, states or even entire nation. But in this INC company network example, a connection between head office to sales branch distance is just 700 meters, a very small distance, and now Tazeen is saying that this is WAN connection or WAN network. But as per definition, WAN occupies a very large area. How could be this connection between these offices is just of 700 meters, a small distance is a WAN network? Yes, you are right, my friends. I said that this is the actual definition you will find on internet when you Google for LAN and WAN networks. As per internet definition, the LAN is limited to a small area that can be home or an office building or campus. And WAN networks occupy a very large area. In real world networking, these terms LAN and WAN actually means the networks which is under our authority, that is company's authority. We say local area network. As you can see in our INC company network example, this whole INC campus area occupies 11 kilometers. Even though if INC campus occupies 55 kilometers or more than 55 kilometers and whole area is under INC company authority, and if we build a network for this whole area, either it can be 55, 100 kilometers, still we call it as local area network. It will be considered as a local area network because the whole area or whole campus network is under our authority. The network which is not under our authority, we call it as WAN network or wide area network, or in other words, the network connected through ISP, Internet Service Provider, we call it as WAN network or wide area network. In our INC company network, the INC head office is connected to INC sales branch network through ISP link. Even though the distance between head office and branch office is just 700 meters, a very small distance, but in real world networking, we call this connection as WAN network, WAN connection. And these type of scenarios you will come across in real world networking environment. Guys, I hope that it's very clear that the network connection in very small area or connection within city or states or even around the globe, when a network is connected through ISP, Internet Service Provider, we call it as WAN link. More technically, the network which is monitored, maintained and troubleshoot for any network issue through ISP is better known as WAN or wide area network. Let me educate you guys more real world networking stuff, which I begin with a question for you. If the WAN link between head office and sales branch goes down, either this WAN link, okay, which is head office WAN connection, or this WAN link which is connected to INC sales branch goes down, is INC network engineer can troubleshoot this issue? No INC network engineer cannot troubleshoot this WAN link issue because it's ISP WAN connection. ISPs will not provide authentication to log in their network devices to their customers. Who are the customers? We are the customers of ISP. We are paying monthly charges to ISP for this type of WAN connections to our branch offices. We means here INC company. So any company network engineer is not authorized to troubleshoot a WAN issue. Then how to fix this issue? To fix this WAN link issue, we have to open a ticket with our ISP. Now another concern, how to open a ticket with ISP. In real world networking, ISPs provide a unique code which will be mostly an alphanumeric code for each WAN link. In our example, we have two ISP WAN links, a head office WAN link and a INC sales branch WAN link. So ISP provides two unique code for each WAN connection. To open the ticket with ISP, we use the same unique code provided by the ISP and we tag a description that WAN link to our INC sales branch is down. ISP's network engineer will investigate and solve the issue. That ISP network engineer could be you or someone else. From this slide to next few slides, I will talk about network structure in real world networking. In this slide, we will talk about wireless network. However, we all are aware of wired network. If I connect these computers to this switch through this Ethernet cable, then it's a wired network. But we are talking about wireless network. So I have to introduce you guys another network device, that is Cisco access point. Access points send Wi-Fi signals around depending on access point range. Wi-Fi capable devices such as laptops, smartphones, tablets, etc. connect to wired network using this access point Wi-Fi signals. This type of network we call it as WLAN or wireless local area network. So what is a wireless local area network? A wireless local area network that links devices using wireless distribution method within a limited area such as home or office building. This wireless gives users the ability to move around within a local coverage area and still be connected to the network. Wi-Fi capable devices such as laptops, tablets, smartphones which can communicate with access point and join the network. But the computers or PCs are not Wi-Fi capable devices. Computers by design are not able to communicate with access point. To connect computer or PC as wireless device to network, we can use this wireless USB adapter. These are two different types of, there are many types of wireless USB adapters are available, which comes with driver software. Plug this USB wireless adapter to computer or PC to join this computer to wide network without physically connecting Ethernet cable. However, in new CCNA, Cisco has removed LAN wireless from the exam topic. But for real world networking environment, this wireless access points knowledge is important. So we are not going in details in wireless network. What we discuss right now is very brief overview of wireless network. Just you should be aware of this access point fixed on ceilings, walls, all around you as you move in real world networking environment. These access points are connected to our Cisco switch through Ethernet or UTP cable. Enough on access point. Let's move on to next slide. In this slide, let's talk about how cabling and connections look in real world networking. We connect Ethernet cable to the end user's PC or laptop Ethernet port. You can see on your screen, this is the Ethernet port. We also call it as network port or NIC card, network interface card. Most commonly, we say Ethernet port. This is the UTP Ethernet cable. This Ethernet cable, we also call it as patch card or patch cables. This patch cable can be 1 meter long or 2 meters or 3 meters, whatever size required we can purchase. Patch cables are nothing but short little Ethernet cables. We plug one end of this patch cable to these type of wall jack Ethernet ports. These are the different types of wall jack Ethernet ports are seen in real world. This wall jack consists of power socket. These are the two power sockets and also a legacy telephone port with RJ11 connector, and these are the well-known network Ethernet ports with RJ45 connectors. Plug one end of this patch cable to this type of wall jack Ethernet port and other end should plug to computer, printer or server Ethernet port. This is the front view of wall jack Ethernet port and this is the back view of wall jack Ethernet port where Ethernet cable is terminated at the back side of this wall jack. This Ethernet cable from the wall jack, that is from back side of this wall jack, will run all the way through ceilings, through walls and reach to data center cabinet where this Ethernet cable's other end will be terminated in patch panel. These are the UTP patch panels. From these UTP patch panels, we use patch cables of 1 meter or 2 meter or 3 meters of size accordingly to connect to the switches. So from patch panels, we use UTP cable to connect to switch. What is a UTP patch panel? Patch panel does nothing except act as a connector for your cable. Patch panels come with different ports, 24 ports or 48 ports like switches, but patch panels are dumb terminals. They do not have any intelligence. Patch panels even does not require any electricity or power. They act as extension box. UTP cables are terminated here. You can see on your screen, these are all UTP cables are terminated on patch panel. And from this patch panel, these UTP cables will run all the way from ceilings to walls, and other end of this UTP cable will be terminated in wall jack Ethernet port, which we already discussed in our previous slides. You may wonder, well, Tazeen, why do you have these patch panels in between switches? Why don't you plug cables directly to the switch? The reason we have patch panels, because a lot of the time our switches moves, or we want to move cables from one switch to another. If we connect Ethernet cables directly to the switches, then moving of switches is not easy, and to connect to other switch is a nightmare if it's fixed length cable. For example, we have another cabinet beside this cabinet as shown in this slide, which has a switch, and we want to use this switch for our connection from this patch panel. Then just use patch cables whatever length we want to connect from this patch panel to this cabinet switch. Whatsoever this type of connections between different cabinets are not good design. These type of connections are temporary solution. Whatsoever the good design model is to install patch panels and its corresponding switch should be in same cabinet. Patch panels are used in networking. Actually, it's a good design to have patch panels in between switches to allow these simpler connections. In real-world networking environment, you will never find cable connections without patch panels, unless it's a very small company using one or two switches. In this slide, you can see on your screens that UTP cables are punching down in wall jack Ethernet ports. This similar method will be applied to punch down UTP cable in patch panels. By the way, this is the UTP punch down tool used to punch UTP cables. Main distribution frame, MDF. MDF where all IT equipments typically go. It's like a main hub. In these cabinets, you will find Cisco core switches. MDF are the backbone of IT infrastructure. MDFs are installed in data center. The AC temperature of these MDF rooms are set very low. I cannot sit more than 15 minutes in this MDF. It's like freezing. It's very cool. MDF are located in high security zone. Unauthorized personnel are not allowed access to this MDF or data center. From MDF core switch uplink, we run Ethernet cables to IDF, intermediate distribution frame. IDF are small cabinets where we have switch with patch panel or sometimes a server. IDF is a freestanding or wall mounted rack for managing and interconnecting cable between end user devices and a main distribution frame MDF. For example, an IDF might be located on each floor of a multi-floor building, routing the cables from the walls to an MDF. By the way, MDF, IDF or UTP punch down procedure, patch panel descriptions are not in CCNA exam topics. It's real world networking stuff. You have to be aware of this networking stuff. These are actually interview questions mostly asked by employers to network engineers. Employers need their network engineers to aware these networking stuff. In this network structure slide, we will talk about cabling, that is Ethernet cables. There are two popular Ethernet cable types are UTP and fiber optic cable. The good old unshielded twisted pair, better known as UTP cables. If you look inside these cables, you will see 4 pairs. But the thing is to remember about unshielded twisted pair is that in today's modern network, the network speed is growing faster and faster. The speed is increasing by the factor of 10. The first generation network run at 10 megabits per second. The next generation ran at 100 megabits per second. The one after that was times 10, 1000 megabits per second or gigabit per second. And today's newest networks are currently running at 10 gigabits per second. They always multiple by 10. Now you have to have cables that can handle these type of transmission speeds. So they break all the different types of unshielded twisted pair into groups known as CAT levels, that is category levels. such as Cat3, Cat5, Cat5e, Cat6, Cat6a, etc. You can notice on your screens that these UTP cables are twisted. These are the twisted pair. That's the one of the things that makes that one cat level different from another is the number of twists per inch. So more twist per inch is tend to be handle a faster signal. This cable is STP cable, STP, that is shielded twisted pair. These cables are also twisted pair with shield. You can see that this is the shield cover on the twisted pair cables, and even on RJ45 connectors there is a shield. These STP cables are used in networks where you got lot of noise which can cause interference in the network. Shielded twisted pair STP cables protect interference in networks, even lot of noise environment. UTP Ethernet cables are very popular cables used to connect host devices such as computers, laptops, printers, servers, and very rarely UTP cables are used to connect switches. Most of the time fiber optic cables are used to connect between switches. These UTP cables are upgrading all the time. So you have to check out latest UTP or STP cable before purchasing for the company network. So UTP is unshielded twisted pair and STP is shielded twisted pair. Both uses same common connector, RJ45 connector, and the maximum distance this UTP cable can run is up to 100 meters. These are the different categories and the maximum transmission speed for each UTP cable. Fiber optic cables. There are two major categories of fiber optic cables, multi-mode and single mode. Multi-mode fiber optic cable is used for communication over short distance, such as within a building or in campus. Typically, multi-mode links have data rate of 10 megabits per second to 10 gigabits per second over link length of up to 600 meters. Single mode fiber optic cable is used when you absolutely have to have long distance transmission of network data. Fiber optic cables are used to connect our world today and are capable of transmitting information across countries through oceans. Fiber optic cables also work with Ethernet technology, and most commonly fiber optic cables are used to connect between switches. So our INC company network example, to connect from head office to branch office 1 or from branch office 1 to branch office 2, we cannot use UTP cable. It runs up to 100 meters only. Neither we can use multi-mode fiber optic cables. Its length is limited up to 600 meter, but our INC company campus LAN network run more than 11 kilometers. So we have to use single mode fiber optic cable to connect between switches, because a single mode fiber optic cable runs up to miles and miles and miles. Main concern in fiber optic cable is that fiber optic cable has two cable pairs, that is transmit and receive, or in other words sends and receive pair, and they have to have match the other side. These are various connectors for fiber optic cable, like we have RJ45 connectors in UTP cable. If you require to purchase fiber connectors for your company, my advice is to take assistance from sales rep. They point you the right one, as there are lots of connectors available. LC or LC duplex, SC or SC duplex are few connectors I have used in organizations. Now let's talk about SFP transceiver. The small form factor pluggable SFP is a compact transceiver. These are the few different types of transceivers, SFP transceivers. SFP transceivers are direct connected to the fiber cable through its appropriate connector. Most common SFPs are single mode and multi-mode SFPs. SFP Plus is an enhanced version of SFP and is designed to support data rates up to 10 gigabits per second. These SFPs plug into switch uplink ports to connect between switches. Switches installed in same rack or cabinet will be directly connected through fiber optic patch cord or patch cable. But the connection between MDF core switch uplink to IDF distribution or access switch will be connected through fiber optic patch panel. Once again, we are back to our wonderful INC network scenario. So guys, let's connect INC head office to branch 1 and head office to branch 2 LAN network using single mode fiber optic cable. The fiber connections from MDF cabinets fiber patch panel will run all the way through underground tunnels, ceilings and walls to IDF fiber patch panel. From patch panel, we use fiber single mode or multi-mode fiber patch cable to connect between switch uplink port to fiber optic patch panel. Most commonly, multi-mode fiber optic patch cables are used to connect between fiber optic patch panel and switches. The fiber cables will be terminated back to these ports. Or in other words, the cable will be terminated inside this fiber patch panel. The front ports, these front ports are used to connect between patch panel and the switch uplink port. However, SFPs are used to connect fiber patch cables. So first plug SFPs to switch uplink ports. Guys, you can see on your screens is the fiber patch panel. The fiber patch panel function is similar as UTP patch panel. There are multiple types of fiber patch panels with different connectors. However, slicing fiber cable is entirely different than punching down UTP cables. Splicing fiber cables require specific training and tools. We use fiber patch cards or fiber patch cables to connect between fiber patch panels and to switch uplink ports. Fiber patch cables, these are the fiber patch cables, will come in different sizes. In this slide, you can see on your screens that these are network devices: switch, router, firewall. These network devices look and feels are similar. So to avoid confusion in illustrating these devices, we use these icons to represent switch, router and firewall. Henceforth, if I draw a circle that indicates a router and a rectangle box indicates switch. Network topology. To refresh your minds, we will walk through this example. This is a network design, which we technically call it as network topology. Physical design of network is better known as network topology, while logical topology illustrates how data packet flows in a network. The data packet flow in network is known as logical topology. In this network topology, this is a local area network and this is another local area network. Both networks are connected through ISP, Internet Service Provider. The connection from this router to this router, which is linked through ISP, Internet Service Provider, is known as wide area network. To connect LAN network, we use switches, and to connect WAN networks, we use routers. Switches create a network, routers connect networks. Medium to large scale companies or organizations uses this type of connection, which you can see on your screens. A router is used to connect through ISP, Internet Service Provider, to connect other branch office networks. And a separate router is used to connect internet for their employees through ISP, Internet Service Providers. Two routers are used in this topology for security reasons, to keep corporate traffic separate with internet or public traffic. This is the most common network topology used in today's real world networking. In this network topology, you can see a very popular network device, that is Cisco ASA firewall. By the way, it's a firewall icon, which we already discussed about icons. Firewall is used between internal network, that is company internal network, and external network or public network or our big bad internet. This is the most common network topology in today's networking world, because today with all threats, to protect company internal network from public network, company has to has firewall installed in their network. Adaptive Security Appliance. ASA firewall is a security device. ASA is the first line of defense in many organizations' network infrastructure. ASA firewall prevents unauthorized access to internal and external network. By the way, ASA firewall is not in CCNA routing and switching exam topic, but it's a Cisco security exam topic. At least you have to be aware of this type of network topologies where network traffic flow from internal network to external network through firewall. Understanding this type of topology will help you to troubleshoot network issues between internal and external networks. Different types of networks: data, voice, and video. Guys, bear with me. This topic is completely beyond the scope of CCNA exam. Once again, we are stepping up beyond the exam line. But this knowledge is most essential and valuable for real world networking environment. As a matter of fact, the network engineer who has all the additional networking knowledge beyond the CCNA certification will extremely have better job opportunities than just certified candidates. My dear friends, you may know that our YouTube CCNA video series name itself says CCNA exam certification and real world networking. Getting CCNA certification is absolutely important, and acquiring real world networking knowledge is as essential to get immediate job after passing CCNA. Keeping this in mind, my goal is to take you guys from minimum knowledge of networking to the maximum knowledge of networking through this free YouTube channel. This full video is a door opening towards real world networking experience. I know network engineers personally who passed CCNA and appointed as Cisco network engineer in an organization, but were extremely confused with real world networking environment. Like this guy, exactly like this guy. They were scared and keep calling me just to know what is MDF, IDF, what are UTP or fiber patch panels, and what are the single or multi-mode SFPs. By the way, these are the basic requirements in any organization. Guys, I have to tell you many stories of real world networking, how newly appointed network engineers facing problems due to lack of real world networking knowledge. I admit I also started my career with lots of doubts and confusion, but time does not permit me to tell all those stories. So I focus on my goal to provide you more and more real world networking stuff so that you should not be in such situation that freak you out. So this video series is a big series, more lot of stuff has to come in upcoming videos. If you think I just want to pass CCNA exam, for those guys my advice is to skip the stuff which is not in CCNA exam. But once you are CCNA certified, get back to this full video series again. Watch this full series from beginning to end. I hope this series will help you to get the CCNA certification and also help you to pass the interview and get a better job as network engineer. And of course, this series will help you to work on live network with full of confidence but no fear. So let's continue our journey understanding different types of networks. Back in the days, we had these different types of networks: data, voice, and video. These different networks all transmitting different kind of communication. Networks based on IP addresses or TCP IP is our data network. Networks transmitted data using analog or digital signaling or telephone or PSTN network. This is our IP based network where all the communication or data packets travel in network based on source and destination IP addresses. This is our TCP IP based network. These blue links are PSTN or telephone analog or digital based networks where employees, staff members can communicate with their colleagues, and they can also communicate with outside world through this PSTN cloud, that is public switch telephone network. By the way, STC is Saudi Telecom Company, as we have BSNL in India. These are separate networks: data, voice and video. Voice network was separated with the data network, and data network was separated with video network, and video network was separated with voice networks. As these networks were using different transmission method to communicate, so it was very difficult to integrate application between these different form of networks. Organizations had to purchase expensive softwares to integrate between these different types of networks. Integration was entirely software based, and each network is its own world. Each network has their own infrastructure, equipments, maintenance staff, and even cabling structure was entirely different to one another. This was the old legacy network strategy, but still these networks exist in today's modern network, but slowly fading away. Even PSTN or telephone networks are shifting towards TCP IP based networks. Cisco and other networking vendors' goal was to unify all these different types of networks, and they accomplished their goal. Now in today's modern network, we have these data, voice, video all go across the same network, that is TCP IP network. These all different networks are merged together and are using common transmission method, that is TCP IP. This type of network is known as Unified Communication Network, and it's a modern network strategy. Unified Communication Network strategy is taking up the world. This is an example of TCP IP data communication network. These two networks are connected through ISP WAN link. This network is based on TCP IP network, that is source and destination IP addresses. Don't worry guys, we have full dedicated video for TCP IP in upcoming videos. You can see on this slide is an example of unified communication network strategy. In unified network, all these separate networks, data, voice, video are merged together and can transmit or send data packet through this same media based on TCP IP. As I had already illustrated in my first video, that every data packet on network has source and destination IP addresses to travel packet from source to destination. The transmission of data packets between these networks, that is either email data packets or phone conversation packets or any video conferencing packets, all travel through these single media. These data, voice, video packets are converted to binary, that is zeros and ones, and the transmission is based on TCP IP. Now let's briefly talk about voice over IP style of communication in TCP IP based networks. At INC head office, phones have 3XX extensions, that is 3000, 3001, 3002, so on. Similarly, branch office phones are assigned 5XX extensions, that are 5000, 5001, 5002, so on. All phones at Hyderabad head office can call each other using 3XX extensions, and head office staff members can also dial 5XXX extensions to call Bangalore branch office employees. Similarly, branch office employees can call each other dialing 5xx extensions, and they can also dial 3xx extensions to call head office employees because these two networks are connected. These type of phone calls are technically known as on-net calls, and all on-net calls are free of charge. As long as our INC company has branches and network connections all around cities, within nation, and even in other countries, the calls between all these branches are still on net calls, and all phone calls are free of charge. The phone calls to other telephones such as local calls within cities or national calls or international calls or even calls to cell phones, all these telephone calls will be diverted through PSTN cloud, public switch telephone network. These type of calls are technically known as off-net calls, and all off-net calls will be charged by PSTN, public switch telephone network, because these calls are not connected to our network. These all telephone calls are diverted through PSTN. The main advantage of this unified communication network is that everything is unified. Infrastructure, equipments, staff, and even cabling has been unified. Guys, I have seen staff consolidation in many organizations. Companies are hiring employees who have both Cisco routing and switching certification and Cisco voice certifications to handle both data and voice and video network. But why we are discussing this topic in this CCNA routing and switching series? Good question. Thanks for asking this question. I will try to answer it. Because you can see on your screens that an IP phone. By the way, a phone connected to our TCP IP network, we call it as IP phone. So this Cisco IP phone is connected to our network device, network switch. And a new type of connection, you can see that this computer is connected to Cisco IP phone. This computer is not directly connected to switch, but it's connected to our network through Cisco IP phone. Modern switches supports to connect two devices, IP phone and computer, to a single switch port. Modern switches are designed to separate data traffic with voice traffic. But the network engineer has to configure these switches to transmit this both data and voice traffic through this switch through a single port. So in future switching video in this series, we will learn how to configure switch port to support both data and voice traffic to transmit to our network. However, configuring a switch port to support both data and voice is not on CCNA exam topic. But I will go beyond the exam topic and educate you, my friends, to configure a single switch port to support both data and voice traffic transmission to the network. What we have understood in this video, we are quite clear that this video series is not just pointing CCNA exam topics, but in addition this series is covering real world networking experience. Finally, in this video, I have accomplished my goal to explain the full concepts of networking, because understanding the concepts of networking is winning half the battle. We understood the types of network, LAN, local area network, and WAN, wide area network, both internet definition and how these terms are used in real world networking by just walking a real world networking scenario. We spent few slides to discuss network structure such as Ethernet port, Ethernet cable types UTP, STP, fiber optic cables and its connector types, and we have also seen visuals of MDF, IDF, patch panels, both fiber optic patch panels and UTP patch panels, etc. And finally, we have seen examples and understood both legacy, old network strategy and unified communication network or modern network strategy. I hope you enjoyed and thanks for watching this video. And please don't forget to subscribe for latest upcoming videos. For full channel access, click the link below in description.